I've been a bridge engineer for over 30 years, designer and director of large infrastructure projects. Currently, I'm the project director for the Governor Marion Cuomo Bridge, which replaces, thank you. I gather you know it. It replaces the Tappan Zee Bridge over the beautiful Hudson River in New York. This $4 billion transportation project is one of the largest in the United States, certainly the largest in New York. And in order to give a sense of scale for those who have not seen it firsthand, I'd like to show a quick video. Well, I'm often asked, how did you end up becoming an engineer? I guess I don't look like a typical engineer. And what does it take to lead these mega projects? Well, for me, it started here. As a 4-year-old, my dad used to take me to the park pretty much to get out of my mom's hair with the baby brother. And he let me climb these tall pine trees as high as I wanted. And that actually served a couple of good things. He used to tell me that I could be anything I wanted as long as I, worked hard, reach beyond your grasp, and don't settle for the easy path. And as a 4-year-old, that analogy was okay, because I could understand that with the tree branches. And it was important because in the mid-60s, there were not a lot of female role models in the workforce. So having your father say it meant it could be true. I would say that when I became a teenager, I started in a really great liberal arts school in New York City. And I knew, like my classmates, that I really wanted to pick a career that would be a positive contribution to society, at least most of my classmates. Something that would have really meaningful in the work. And I started as pre-med. And a couple years into my college, I saw a course in the curriculum called Biomedical Engineering that was offered across the street at the engineering school. Well, actually way across campus. And I decided to take it. I had not even known an engineer, never met one, had no clue what engineers did. When I started to take this class in the engineering school, I found out what engineers really did do. They actually use math and science and apply it to solve real-world problems. How cool is that? So I applied to the engineering school, still finished up my liberal arts degree, and started working in my first year of engineering school. I found it a little challenging, to be honest. I didn't have the technical background coming from the liberal arts program that a lot of the classmates did. They all came from technical high schools. So my first year in engineering school, I used to sit in my desk doing my homework with stacks of textbooks around me, trying to catch up and learn the solutions to my homework problems. I made it through. It got better after the first year. But I graduated, started as a structural engineer in a highway, transportation, bridge, and building design company. And during my first year at work, I still was in the habit of having my textbooks on my desk and looking up, the solutions to the problems. And my immediate supervisor took this as initiative. And lucky for me, because he went to the firm's partners and said, look at that girl, she works so hard. Why don't we promote her to a project manager of a small bridge, let her do it. And the partners looked at him as if he was crazy, and they said, no, she's way too young, and we've never had a woman project manager before, so what are you thinking? So a week later, my supervisor went back to the firm's partners, and he said, how about this? Let her be the project manager of this small bridge. It'll be really good for her to learn everything about a bridge, from the beginning to the end, even though it's small. And I'll check in with her from time to time, and this is all the money you're going to save because she's running the job full-time and I'm not. And the partner said, yes. So I really have that first boss to thank for really trying to give me an opportunity. I went on to more challenges. Bigger bridges, more complex structures. This is the Bear Mountain Bridge, actually. I was the design manager, the project manager for some of the reconstruction work. And so I always raised my hand for the more complicated projects. Again, reaching beyond your grasp, rising up to challenges. So I would say a couple of important things if you want to manage big projects is to first really know your subject matter. Be an expert at something. And the second is to not be afraid of daunting assignments, of risks, challenges. You're only going to excel if you really put your mind to it. So definitely the echo of reach beyond your grasp was with me. An even more challenging project was adding a lower level to this suspension bridge in Lisbon, Portugal. Now, this bridge was the longest bridge in the world when it was built in the early 60s by a famous bridge designer called David Steinman. 30 years later, the Portuguese transportation officials pick up the telephone, and luckily I was working for the eponymous Steinman Bridge Design Company, and they said, can you add that lower level that we're talking about 30 years ago? And of course we said, yes, we will do that. But it wasn't so easy. In fact, there had not been suspension bridge building for 30 years. The last was the Verrazano. And there was not a lot of transfer of knowledge in that generation because nobody was really building them. So I was the I represented the designer for the construction phase of this project. And I had to rely on one of the firm partners who was very, very elderly and in the hospital. And although he was, physically not doing well, his mind was still sharp. And he was around for the first suspension bridge building. And he would fax me from his hospital bed sketches and details that I would then take with this flimsy fax paper, go on the airplane, and then go to Portugal and explain to the builders how things should be. Now, spinning cables that were added to the suspension bridge is quite a difficult thing to do. It's not, and cables, by the way, are made up of thousands of wires, probably the diameter of a pencil. So each one of those big cables that you see that go like this, that actually has to get spun from shore to shore, almost like a bobbin and a spool in a sewing machine. Each wire is dragged, pulled across the river, another one picked up and brought back to the other side of the shore, again and again, can you imagine, thousands of times? And then all that cable is compacted, so it looks like a pipe, but it's not. It's really thousands of strands of wire. And it all gets pulled down into bedrock and anchored. Also, the vertical ropes had to come down between the existing vertical ropes and go catch the lower level that we were adding for railroad. So they asked us to put a railroad on because the bridge was so congested. It was basically a 24-hour-a-day rush hour. And they said, well, you make the lower level for railroad, can you also widen the bridge a little bit for us? Why not? And it's not just putting extra cables to pick up the heavy weight of the railroad. We had to actually lift the bridge up and then put it back down so both cables were sharing in the right proportion of load, which was very tricky. I don't know if it was ever done before, but we successfully did it thanks to the old guy who was helping me. Now, I mentioned that there are a couple of important things to learn to be or do to manage these big projects. One was really knowing your subject matter deeply. Two, taking challenges and risks in your work. But the third one, which is actually just as important, if not more, is the ability to take your team and get them all aligned to the same goal. And that's often where a lot of leaders kind of fail, because you're dealing with humans. You're dealing with hundreds of people on projects like this, and not everybody has the same agenda. And you have to convince them that although personally you may not be liking my decision, you have to cooperate and collaborate because we're all reaching for the same goal at the end. So the most effective leaders are ones that can convey that vision, that motivation, and it's usually ones that have passion, that think they can change the world and do a little bit better, even if it's just making a public works project. Because if you believe it, your team will too. A lot of my colleagues really have the passion for what they're doing, and they like to cast a wide reach to help other people because they do believe they're changing the world for the better in little bits. I belong to a foundation, a nonprofit called Bridges to Prosperity. And in this organization, we go to places in the world that communities are suffering from rural isolation. Basically, these rivers flood maybe 4 months or more out of the year, and what looks low-lying here becomes a raging, very dangerous river that children can't go to school. People can't get health care across the other side of the river without actually risking their life, and some do die, or even bringing their goods to market for 4 months of the year. So by building a footbridge, and I have colleagues who are contractors, engineers, and a lot of university students who volunteer for these builds to help, and actually, when everyone's pulling in the right direction, the teamwork, what you get can be amazing. So here, the locals with contractors, engineers, students, all pulling to create this bridge. We go to areas in South America, Central America, Africa, India, the ones most cut off from the communities on the other side of the river. And they use local materials. Obviously, the cables are donated by some contractors or some ports that don't need to use so much cable. But all the other materials, the locals learn how to do it. They help build. So the concrete or the wood planks that come from the wooded area, so that they learn actually some trades, and they also learn how to fix their own bridges. Do you ever see children so happy to go to school? So right here at home in New York near the bridge, we have a really great outreach program. We have a number of people on our staff who've already touched 50,000 students, teaching them science, technology, engineering, art, and math all through the project demonstrations. It's a really fantastic program, children of all ages, even seniors and other people. But using the bridge as an example so that children are aware that there are professions like this, because we really do need boys and girls to get into engineering to continue to fuel American innovation. We desperately need more engineering students. And it's really great for the girls to see a role model. My role model in the Tagus Bridge, when I was going on that airplane, was actually Emily Roebling. You know, I knew she went with her directions from her ailing husband to the bridge site, and I would think, how courageous was she to have done that at the time she did it? So when I was a little bit nervous about taking those details from my ailing mentor and going to Portugal, I thought of her, and that was my role model. Here, the girls get to see somebody a little bit more in their century. Now, I'd like to ask you, whatever it is, your skills, talents, hobbies, try to reach out and share it. Try to teach the next generation what you know, because you never know who you may inspire someday to reach beyond her grasp. Thank you.